Thank you to moderator. And first of all, I would like to express my appreciation to Department of Mechatronic Engineering, FITech, Faculty of Science and Technology for inviting me. Indeed, it's a great honor to be here. And before I start, I'd like to introduce myself again. My name is Dr. Noraiman Skindar. I'm currently working with Department of Manufacturing and Material Engineering. Well, previously, as mentioned by the moderator, I was working with Polytechnic Kuching, located at East Malaysia, and more than 7 years, almost 8 years. And my specialization is on the additive manufacturing. My PhD project was on the developing a new nozzle for printing biomaterial. So we get patent on that particular nozzle. And so today's topic is on the application of 3D printing in food industry. So we implement the 3D printing technology in food industry. The main objective or the main target is basically to help the company. We're focusing on the SME, which is a small and medium company. So of course, when we're talking about the SME, small and medium company, of course we want to reduce the cost. So yeah, we able to reduce the cost. We able to reduce the overall manufacturing cost, and the company are happy. They were very happy, and yeah, we'll share some of the projects later on. So this is my outline presentation. We'll go briefly on the introduction to 3D printing technology, and then I will go to the project background, and also we'll touch on the problem faced by the company, as well as the project details, so some of the design, some of the printing parameter that I used in this project, and a conclusion as well. I will share also the project which also related to 3D printing technology. Well, just briefly on the 3D printing technology, I believe all the participants already familiar with the 3D printing technology. We know that 3D printing technology or additive manufacturing, sometimes people call rapid prototyping technology. We have we can classify into three major categories actually. Either is powder base, liquid base, or solid base. Powder base, we know that some of the example of powder base, we have SLM, selective laser melting. Liquid base, we have a SLS, selective laser sintering, as well as solid base, we have a FDM, fuse deposition modeling. Well, this fuse deposition modeling is a very popular one because of the cost, of course, a very low cost, and yeah, it's actually very easy to operate. And now, before I go further with my project, I just want to share why actually now currently the company is shifting toward the 3D printing technology. As you can see from the graph that starting from 2007 up until 2020, actually, the trend is increasing. Okay, the demand by using the demand for the 3D printing is increasing, regardless of any type of 3D printing is increasing. So this is actually good opportunity for those who are actually involved in 3D printing technology. They are very a bright future for that. As you can see, the graph is dramatically increased from 2007 up until 2020. And of course, now we are moving toward the industrial revolution 4.0, and 3D printing or additive manufacturing is one of the elements that can support the industrial revolution 4.0. So this is, we can see that the 3D printing technology is actually a very important one. And now I think we are familiar that we are talking about the sustainable development goal or sustainable manufacturing process. Everything is, currently we are talking about sustainable. Now 3D printing is actually one of the sustainable method. As you can see from the SDG, 3D printing can contribute to SDG number 12, which is responsible consumption and production. We know that 3D printing technology can reduce a lot of waste, can reduce a lot of cost. So yeah, it's ultimately contribute to the sustainable development goal SDG number 12. And as well as we can say that it can contribute as well as number 9, industry innovation and so on. And we know also that the biggest advantages of 3D printing, we can create a lot of complex structure. So it is actually very suitable for the customization product. Now, before we go further, for this project, I have to choose which of the best 3D printing technique. So in this project, I choose FDM, or fuse deposition modeling. I actually consider a few technique 3D printing to for this project, but when I look into the overall project, that I have to consider the cost. So of course, because we are focusing on the SME, small and medium enterprise. So budget is the most important one. So we have to consider the cost first. So and also as in the overall, so FDM is the best. So why? Because the first one is of course because of the cost. Yeah, and also now currently we can have a variety of material can be processed using FDM, and yeah, it's easy to operate and easy to print a prototype. We need for this project we need a lot of prototype. I need to do a lot of testing in the company, so that's why I have to have a lot of prototype fast. So that's why I choose fuse deposition modeling for this project. Now, just slightly on the project background. So this project is funded by the Malaysian government under the PPRN. It's also mentioned by the moderator, Public-Private Research Network. This grant is actually between the academia as well as industry. So we need an industry to apply for this grant. So yeah, we have to come to the industry, ask them what are the problems they are facing. So we try to solve their problem, and then coming back again, do the proposal work, and then do the presentation to the ministry to try to solve the problem facing by the company. This is actually the initiative by the Malaysian government to help the SME. And the company is, I choose the company Organic Gains Sdn Bhd. Just slightly on the company profile for the Organic Gains Sdn Bhd. Established in 2014, having a principal activities like research and development, doing manufacturing and sale of organic product. Is focused on the food service and also retail foods product. And one of the product, for example, we have chili blended, ginger blended, lemongrass blended. A lot of products is basically ready to eat. We also have a coconut milk, and also we have we call it as in Malaysia we call it as a rendang paste. So it's like what? It's spicy one, yeah. And now currently the company facing problems to meet the demand from the customer. A lot of customers come to the company and then ask them to, to provide them a variety food packaging sizes. But the company currently they only have two set of food holder, which is for 1,000 gram or 1 kg and 200 gram. So they can only fulfill the demand if the customer want to have a food packaging size for 1 kg as well as 200 gram. So this is actually problem faced by the company. So we need actually to solve the problem faced by the company by finding the best solution. They can the conventional method of fabricating this food holder, the white one here, food holder, is very expensive using what we call the conventional machining. It's very expensive, around 30,000, yeah, 30,000 for one set. So it's not cost effective for the company, especially for the SME, small and medium enterprise, to invest that amount of money, yeah, 30,000 for one set. Imagine that if the company need a lot of set, 5 set or 3 sets, so they have to like invest almost 100,000 ringgit in Malaysia. So it's not a cost effective. So that's why we currently they only have a 2 set of food holder, yeah, 1 kg as well as 200 gram. So that's why actually we propose them, the company, why don't we use implement the 3D print technology to develop and fabricate food holder, so we can cut a lot of costs and we can reduce a lot of time of manufacturing time, so we can help them, yeah, to fulfill the demand from the customer, and eventually will increase the profit from the company, because when the customer come and then they can easily fulfill the demand from the customer. Yeah, if they want 100 gram, then we can make a food holder for 100 gram food packaging. If they want a 300, yeah, we can make it, because the cost for the food holder is reduced a lot when we are implement the 3D printing technology. Previously, they only have a conventional method, so it's very expensive. So that's why we come and then we propose 3D printing technology. Now this is the filling line in the factory. You can see the white one is the food holder. On the right side here is the blower, the blower air pressure. So this blower is basically to blow the pouch or food packaging. We call it as a pouch to open, and then going to the next step is filling. This is the filling process where all the coconut milk, all the paste, all the food product will come in, into the porch, and then the last one, the third stages, is basically the sealing process. So this is three main processes which is very important in the production line for the food industry for this company. So the food holder must meet all the requirement on these three stages. Otherwise, the production will fail. So we have to fulfill all the criteria. So I will share some of the criteria that we have to consider to develop a food holder. Now, overall, the project objective, we want to design three type of food holder, which want to cater 100 gram, 300 gram, and 500 gram. This is actually that have a lot of demand from the customer. So we focus on the 100, 300, and 500 gram. And we want to implement, fabricate the new food holder by using a 3D printing technology. And our aim, as I mentioned before, we want to reduce the overall manufacturing cost. And this is the flow chart for the project. So we need to identify the criteria, the critical criteria of the food holder. Then we have to design, and then we choose the material for the food holder. So as long as it's the biodegradable, it should be okay, because we don't have a direct contact with the food. So PLA plus, I think, is the best for this project. And then we setting up the 3D printing FDM, all the printing parameter, the best printing parameter, and also installation of ball bearing. There is a lock on the food holder, and installation, and we did a lot of tests to make sure that the food holder running smoothly. And then the last one, yeah, we have to validate the food holder. Now I just want to share you some of the testing procedure, method, and verification during the project. So this project is actually already completed. We have three phases. The first one, yeah, of course, we have to design, and then second phase, we go for the verification using FDM, and then the last phase, we're gonna test. So we did some of the analysis using DOE. So we list out the critical criteria, and we did a DOE to see which criteria that affect the most on the food holder design. So the first one is a pouch design. This is also criteria that we need to consider. This example of the pouch, the silver one here, the pouch, or we can say that food packaging. So height, width, and 80% of the filling we have to consider on our design food holder. You can see 80% of the filling, the food holder height must be below 80% of the filling, because above the 80% of filling, we need to have a space for the sealing process on the third stages. So that's why on the some of the consideration, we have to make sure that the height of the food holder is below 80% of the filling. Now this is some of the example on the conveyor, the dimension of the conveyor. We have to measure the lock pin as well, and just want to share with you. Also, the other criteria that we have to consider is slotting dimension. If you can see the red circle here, this is the slotting dimension. So the slotting here is also very important. Too wide, the pouch will misplace. If this the slotting is too wide, and the pouch will eventually misplace when the process blowing the pouch takes place. And then if too tight, then the pouch cannot be open. This is also very critical. So we need to have actually a specific dimension for every food packaging or pouch. Now the next one is on the elbow length. This is also a very important one. The elbow length is basically the function is to hold the pouch after we blow. Yeah? Otherwise, when the blowing process takes place, if this dimension is quite very simple, but it actually affect the most. Even for different in 1 mm, the pouch will not stay open. So that's why this is actually very important. So we did analysis to see what is the best dimension and what is the specific dimension for every pouches. Alright, so this is the overall food holder fitting assembly. This one is the sealing level, so we have to mark that line 80% filling, and to make sure that the food holder is below, the height of the food holder is below the 80% of filling. And also this one is the prototype for the conveyor. Now, for the printing parameters, I just want to share with you. We know that we have a lot of printing parameters. For example, we have a Cura, we have a Repetio. This one I just want to share Idea Maker. I think Idea Maker is a bit interesting. Generally for this project, I just want to share with you the infill percentage. I just using 50% is good enough for the project, and then the layer height is 0.2 mm is good enough for the quality. Overall quality is 0.1 is superb, but the printing time is too long, which is not cost efficient, and also the printing temperature plus minus are in 190, 195, and material I'm using a PLA plus. I think I will share some of the idea maker slicer. I will just want to share with you. Let me escape this one first. Alright, hopefully you can see this is the idea maker interface. So you can see this one, I like the interface. It's quite interesting compared to the Cura. Well, anyway, everyone have a different perspective, but for me, I think idea maker is for me. I really like the interface for idea maker. For example, we have the product here, or we have the design. So everything is quite similar compared to the Cura or Repeater. You just go to the edit. So this is where you can actually setting up all the printing parameters. There are a lot of options, which is good and which is bad. The good is if you are already expert enough, you can tune a lot of things to get a better printing quality. But if you are actually a beginner, then once you look into this option, then you got a headache. Which one I have to choose? Which one I have to setting? All right. But anyway, this is the layout. The normal one. We can set up all the shell, the first layer setting, first layer height, and this is actually quite similar like Cura. But I think the interesting one, if we go to the temperature, we can actually control the temperature every each layer. Well, we know that we have hundreds or thousands of layers, but if we want to actually control the layer, some of the design or some of the prototype, we need to control the temperature. Especially if we have a design like the small one. Yeah, for example, like a tower. Okay, the base is big. Yeah, the base is big, but at the end, on the top, is a very small one. Okay, a very small one on the end part. So the small parts, basically, we need to adjust or we need to control the temperature as low as we can. Too low, yeah, it will actually clog the nozzle, but it's too high, somehow you can you not get the desired printing quality. Yeah, so controlling the temperature is actually very important, especially the small part. So we have an option in Idea Maker, so you can use a temperature control list here. I just want to share with you. I think this one is quite interesting. Previously, I was using Repeater and Cura, but when I see Idea Maker, also they have a free software available. So I try this slicer. So for example, layer one, we want normally layer one we set high temperature to make sure that the, the material is stick to the bed, okay, for providing a good adhesion. So layer one, for example, this one is the bed. You switch to primary extruder. So for example, as layer one, normally I will put it as 215 or 216, and then add temperature. So we know that on the layer first layer, the temperature is 215. For example, the last layer I want to set up 190 because it's a very small part. For example, tower. So I will just put, for example, the last. We can see the last layer, how many layers we have after we slice. For example, the last layer is 250. I just want to set a 190. So I just add the temperature. So we know that the software will automatically adjust when up until the last layer, 251. Or normally we can start from 240 before the end of the layer. So we start to reduce the temperature at 190. So I think this is one of the good option that the Idea Maker have. The heated bed as well, you can also check, you can also make an adjustment. Okay, for example, first layer or second layer. And normally if you want to easy remove after you print out, so yeah, the last layer, you can put the temperature, you can reduce the temperature. So it can just pop up from your heated bed after all the printing process is finished. All right, and overall the speed advance, the ooze also is one of the issue in FDM. So we need to control that. We have to actually try and error this one. You have to experience that. We know that a different material also poses a different ooze setting sometimes. So yeah, retraction, all the things you have to consider as well. So I just want to share with you some of the, I think the option that is a good option in Idea Maker. Right. So yeah, it's very normal. Then we go for the slicing and then preview. So we can preview the printing. Right. So this one you can check layer by layer. Okay. So now we have 100 and. All right. So stop. Just continue my slide. All right, some a little bit on the theoretical knowledge on especially when we design a whole, because in this project, yeah, one of the criteria that I have to consider is whole design. So we know that on the let me on the right side here, the slicer diameter is different with the actual diameter, the printed one. So we have to consider this one. We have to be very careful on this one. Slicer diameter is different on the slicer diameter, and also actual diameter is different. So what happens is that as nozzle print the parameter of vertical axis hole, it compresses the new printed layer down onto the existing buoy layer to help improve addition. So this is the slicer diameter. For example, it's supposed to be 0.2, but when it print out, so the newly printed layer will actually compress the existing layer. So, so what happened is that the hole is actually a little bit smaller compared to the actual one. So this is the consideration that we have to take. Yeah. For example, a hole design with 5 mm diameter may be printed with diameter around 4.8, yeah, because it's compressed the previous layer to make sure that each layer is bonded together. So therefore, it's the best practice to design oversized hole. So this is the consideration. So I did in my project. I have to design a little bit larger compared to the actual one, so that it can compensate this situation. And printing orientation also is very important. If you can see, this is the left one and the right one, so it's different. The right one I printed horizontally. The left one I printed horizontally. The right one I printed vertically. You can see clearly the layer. The layer is not quite good on the right side. Yeah, even though this is actually the same printer, the same material, but the outcome is different. So you can see the left one is smooth, and then the right one is a bit rough. The setting, everything is the same, but the orientation is actually different. But you can see that the outcome is different. So let me, I can share again my slicer. So this one, let me close preview. So this one on the what we call the orientation. So make sure the orientation is actually according to the what we need. Yeah. So this is, I place it horizontally rather than I place it vertically. Sorry. Yeah. So this one. Okay. So the first one I printed vertically, and then I see the layer is not good, and then I printed. I just want to see the difference, and then I printed horizontally. So the outcome is good, as you can see from the figure. The left one is very smooth, and then the right one is quite rough. The setting, everything the same. The temperature, all the printer, even the material, everything the same. But only the orientation, but the outcome is different. So those also the thing that we have to consider as well when making the prototype. All right, I just want to share some of the 3D printing process for the food order. So we are printing two pieces time. And this is a printing prototype for 100 gram food holder fit into conveyor. And this is also 100 gram. This is the pouch, yeah, 100 gram. And this is for 300 gram. This is for 500 gram, a little bit bigger. And also I want to share with you the installation and testing that we did on the company. Some of the picture installation and testing. So this is the testing. I will share with you some of the video. Let me stop sharing first. I think I have to share the sound first. Alright, so this is the filling line. Okay, so this is the filling line. This one is a dry run. There is no food or what we call normally we're gonna have a dry run and wet run. Wet run we fill in with the water. So this one is just a dry run. So the nozzle, the first step is blowing. So the blowing is to make sure that the pouch open and the food holder will uh, hold the pouch stay open. So this is actually quite important, very important when we go for the next step is for the filling. And then, sorry, this one is for 300 gram. Right, and then, okay, once again, so blowing, and here we go. Filling, and the last one we go for the sealing. So this one for 300 gram, the same thing, we successful. The blue one. Right, then the last one is 500 gram, also successful. So well, actually we did a lot of tests before. So this is just show you some of the tests that successful. Alright, so this is how basically how it works. Right, this one I just want to share with you how actually the overall production in the company run. Actually, I'm talking in Malay, but on the left side here, I already put the some of the subtitle on English. So I just play the video. So this is the first step. So this is the filling line. Right, so this is how actually the production run. We start with the blowing process, and then we go to the filling, and then the last one sealing. And you can see this one we're gonna have a quality check. So normally quality check we will do manually. We check one by one before we go to the next process for the labeling and so on. Now this one, I just want to share with you. This is actually Chief Operating Officer, Muhammad Adil bin Dato' Abdul Wahab. So they are in charge actually for this company operation. So they are very satisfied with the project and yeah, give good impact because yeah, SME as I mentioned before, the concern is on the budget. So we can reduce a lot of cost. As I mentioned, 30,000 for one set food holder. So we can reduce only 1,000 or 2,000 ringgit. I will share some of the data later on. So they are very happy. So we can have a lot of variety of food holder. So if the customer comes and then they want a very specific packaging size, we can do it for them. Yeah, because we cut a lot of costs. Previously, as I mentioned, we are using what we call the conventional machining. So it's very expensive. So as mentioned, it's not cost efficient for the company to invest a lot of money for the food holder. So that's why they are searching the best alternative to do that. So we come and then we propose the 3D printing technology. So I just play the video. So overall, they are very happy. And again, after we completed all this project, the company gave another project which also related to food order because they already have the other demand from the customer. So we'll also share some of the project. It's a running project actually. It's not completed yet, but I will share some of the picture of the project later on. Now, if you can see from the graph, the comparison, the left one, the comparison of manufacturing cost of the food holder using 3D printing technology and the conventional machining method. If you can see, the conventional machining method is 30,000. This price is basically, I'm quoting from the company. They give the data. And what we are proposing is 3D printing technology. As you can see, only 1,100. So compared to the conventional machining, so reduction for fabrication cost almost 96%. So as I mentioned before, the company happy. They are very happy. So we can, they can after this they can fulfill a lot of demand from the customer. And in terms of the fabrication time also, we reduce almost 72% of the food order using 3D printing technology compared to the conventional one. So the blue one is basically 3D printing technology, and then the other one, the orange one, is basically referring to the conventional machining method. This one is on the hours. Yeah, we're talking about hours. On the blue one is 3D printing, and then the other one is orange one is for the conventional machining method. So on the objective, yeah, we achieve the objective. We can reduce the cost of fabrication, and at the same time, we can reduce the cost of uh, uh, time of fabrication cost, overall manufacturing cost, and also fabrication time. We can reduce both. So yeah, at the same time, eventually the company will gain or increase the profit of the company. Now this is the current project, running project. As the company are happy, they are also requested another one. This one is a bit different. What we call this one is like a plastic jar. They want to make another new product for the company using a same filling line, but different product. So normally this filling line, they can have a lot of products as long as you can actually altering the or manipulate the food holder. If you want to have a plastic jar, then we have to alter the food holder. If you want to have a pouch, then we have to actually design the food holder according to the pouch. So because we can offer a very low cost food holder, then the company asked another one. So this one currently they are focusing on the plastic jar, and maybe the next one a different sizes. So this one is for, if I'm not mistaken, the product for the I forget the product. What we call peanut butter. This one is for the peanut butter. So currently we are preparing the food order. I think within 1 week or 2 weeks we are able to deliver to the company. So I just want to share some of the. This one is the testing done in the company. This one I just do it manually first. This one just do it manually just to test whether this plastic jar will fit to the conveyor. And then this one is a wet test. Just put in a water. It's not peanut butter, it's just water to see whether it's work or not. Alright, so this is how it works. Then once again, alright, so the test is successful. So now currently we are making 80 pieces of this food holder. So within, as I mentioned, within 1 or 2 weeks, we will deliver to the company. Alright, I think that's it for the application of 3D printing to the food industry. As I mentioned, one of our objective is we want to reduce the cost of the fabrication, and also we want to reduce the time of fabrication. So we did that, and we have accomplished. Company happy, and as a result, we have another project with the company as well. So I just want to share some of the other projects which also related to 3D printing technology. I just want to share with you. This one is I think some of you maybe already seen this smoky sand project. This one we want to create a lot of smoke coming out from the rocket. This is actually a collaboration project with the industry as well. Uh, it's not a military
So,
weapon.
I mean, sir, don't mind. Can you speak loud, sir? Actually,
Oh,
here.
is it okay now? Is it
Ah,
okay?
it's okay. Now it's okay.
Okay. So this is a smoky sand project, a collaboration with industry as well. This one is we want to create a lot of smoke. It's just to signal a fighter jet. It's not a weapon also. It's not a weapon or missile. It's just we want to signal a fighter jet so that the fighter jet know the current location. So this we have our CFD simulation, and also if you can see here we did a lot of tests for the smoke. We want to create a lot of smoke. We have a lot of material, try to mix a lot of material, try to have a good combination of material. And this one, the test, I think this one is a fail one. Yeah, this one is a fail one. We did a lot of tests as well. This one is blow up, explode before going up. So it's actually a quite a dangerous one. And then after that uh, after we did a lot of tests. So this one is the accomplished one. So we able to deliver to the project to the company, and all the details. So the next step is we have to did the test, a real test with the fighter jet, but it's supposed to be on the if I'm not mistaken, on the last year, yeah, because of this pandemic, the COVID-19 pandemic. So we have to delay, and we have to, yeah, we will see after this whether we can have the next trial or the real one by using the fighter jet as well. And this is also our project during the COVID-19 pandemic. We did some of the nebulizer replacement, just to share with you. Yeah, this one is we have done a lot on the face shield as well, and mediboard design as well, involve 3D printing as well. And yeah, we get into the news as well, and also television as well, coming in to interview what actually the mediboard is. And this is actually the final version of the mediboard. We have a lot of final mediboard version, and you can see that the first one is very rough one. This one very it's just a box, and then we put electronic everything there, and then we upgrade a bit, and then the last one, yeah, we get the grant, we getting the grant, and then yeah, we can get the proper one. Yeah, currently still in progress, and hopefully we already attract a company to involve in this mediboard, and to actually invest a bit, to make it not only for medical purpose, but also other purpose. It's like a general purpose. Right. So this is the final version of Medibot. So the ultimate objective is basically we want to communicate with the patient, yeah, because during the COVID-19 pandemic, we don't want to get close to the patient. So uh, the original objective is the doctor can communicate with the patient without any physical contact. So the doctor will control the Medibot from their rooms, and then we can talk to the patient using the teleconference there. There is a mic, there is a screen there, so they can communicate what, for example, asking the status of the patient and so on. Alright, so this is a very simple My Sejahtera project. So My Sejahtera is basically just to check all this temperature before coming into the class. This one also involved just slightly on the 3D printing parts. So we upgrade a bit whatever we have on the market. And also I did printing composite material. I'm on the copper as well as on the aluminium. So we did a lot of test analysis to find the best printing parameter. And currently we are working with the try to print totally a metal. I think this one is already we have a lot, especially Markforged already did that using FDM. Normally we are using SLM powder base, selective laser melting, but it's a very high cost. So they are currently switched to FDM. Markforged is initiate the FDM, but yeah, FDM we need a lot of post processing. For example, the binding, sintering, and so on. But we can from there, but we can reduce cost from there. And I think that's it for my presentation. It's very short presentation. I think I would like to have maybe some of the question or discussion or anything from participant as well. So yeah, anything maybe. Alright, Mr. Moderator, anything maybe question from the participant?
Okay. Any questions from the participants?
I put a very short presentation actually.
Yes.
Very short presentation. I just want to share with you that well, actually, I have a lot of data to I cannot share with you, especially this one because it's related to the industry. So I just want to share that this
Yes, sir.
technology is actually can reduce a lot of costs. Yeah, it can help company a lot. Yeah, in reducing a lot of costs. So eventually, will increase the profit for the company happy. So this is, I think, this is the current trend. The company is switching, finding the alternative to get the best practice to cut down the overall manufacturing cost. All right. Maybe any question you would like to ask? Oh,
Any questions, please ask to the speaker. You can unmute yourself and speak to the speaker. Any questions from the participant side?
no, no question.
Okay, sir. I think no question, sir. Sir, Amit, sir, Sukina,
Yeah,
sir.
yeah.
Sir, which material you are used for printing that components for the food packing industry?
For this project, I'm using PLA material, PLA plus
Okay.
material.
Okay.
But for the prototype, we just use normal PLA, quite cheap, just to get the testing done, everything. If everything is okay, we finalize everything, then we switch to the PLA plus. So we know
Is
that
it okay
PLA.
for the food packing industry? Is it any certification is there for the food packing industry? And for,
Sorry.
Is it is it okay for food packing industry? Is that means any harmful to the food?
Yeah, because I'm actually thinking that for the food industry we have a certain criteria to meet. Yeah, especially for the material, because
Yeah.
as you can see, the food holder is not directly contact with the food. It's just to hold the food packaging. So I think the
Okay.
PLA is it should be okay,
Okay.
and we have to also there's a slightly issue actually. It's a good question. There's slightly issue actually. If you are using 3D printing, especially in the food industry, compared to conventional. If conventional, we can have a very smooth surface finish and it's a solid. Yeah, it's a solid. But
Yes,
for the
sir.
printing, it's a layer by layer. Of course, there is a porosity. Even though we set a 100 percentage infill, we set a solid setting, but still because it's layer by layer, then we can have some porosity inside. Yeah, porosity layer by
Yes,
layer.
sir.
So actually, I suggest to the company that in term of the cleaning, yeah, after they done all the production, yeah, after maybe 8 hours, 9 hours production, yeah, because there is some oil greasy and something, so they need to actually have the what we call degrease, like a degrease oil, yeah, degrease. They can remove all the dirt and all the oil, so they have to at least submerge within 1 or 2 days to make sure they completely remove all the dirt and all the oil. So one of the issue on the 3D printing. So we have to take into consideration, especially in the food industry, hygiene is very important. Yeah, hygiene is very important. So we take note that we already discussed with the company. We can reduce a lot, of course, as I mentioned before, 90% reduce a lot, of course, compared to the conventional one. But this uh, this issue you need to take into consideration. So in terms of the cleaning aspect, yeah, in terms of the cleaning after done several production, so you need to have proper cleaning and proper yeah, it's like an inspection cleaning after before you can reuse again. So there's a slightly issue on the hygiene part, cleaning part. So because it's a layer by layer. Yeah. All right.
Sir,
Thank you.
as per your knowledge, which material is good for the food packing industry, sir? Or which is contact to the food?
Well, currently for the FDM, I read a lot on the for the food industry. Uh, Still, because if you are using FDM, even though even though the material is food compatible, yeah, the material is food compatible because of the porosity, yeah, because of the porosity of the structure, is basically can grow the bacteria. Even though it's a, for example, yeah, PMMA is a biocompatible, yeah, but then once we direct contact with the direct contact with the foods, if not proper cleaning, somehow it will the porosity, the porosity structure is somehow will grow the bacteria inside, yeah, over the time, yeah. So those are still in the question marks, yeah. So that's why the cleaning process, everything need to be considered. And if we have a totally direct contact with the food, if in this case my project is not direct contact, then yeah, still we have to consider the cleaning issue. Yeah, we have to take proper step or method to clean everything, the food holder. But for if we have a direct contact, yeah, PMMA we can have a direct contact. For example, PLA plus, even PLA plus is actually biocompatible, biodegradable. Uh, it's good. It's not non-toxicity, but when we're talking about direct contact, because it's the structure itself, yeah, the structure itself is porosity. So yeah, it somehow will grow the bacteria inside. So those are basically the issue. Still, but if we are using other material, other technique or method, I think it wasn't be a problem. Okay, because FDM, one of the criteria, because it's create layer by layer, yeah, it will create a porosity. FPMMA, PLA plus is actually yes, non-toxicity. But
Sir,
once we
apart FDM, okay, even if you are suppose we are using the SLS like that, which material is good for the food packing industry? I'm asking to you, sir, if you know anything. Hello, sir. Hello, sir. Hello.
exactly for the SLS, which is
Yeah.
food compatible,
Yes, sir.
and yeah, I'm forgot the name. but it's biomaterial. The resin, yeah, the resin, bio compatible and biomaterial is good. You can have a direct contact with the food, but the problem is, yeah, in terms of the cost, is too much. Yeah, I think yeah, it's not the double, it's triple something compared to the FDM. I actually considered that one as well for this project, but because of the cost is too much, and so I switched to FDM. Because why? The first criteria, because it's not direct contact with the food. If direct contact with the food, then I cannot use the FDM. Yeah, those are basically the criteria that I have to consider. Right.
Okay, sir. Thank you, sir. Sir, one of the participants he is asking about, sir, can you share features of the Mediboat?
Okay. The feature. All right. Right.
Yeah, features, all those
So,
things. If
the feature.
your time permits, can you
Yeah.
show something about that Mediboat?
This one. Yeah. Alright, so this is actually the Mediboat design. Some of the feature is basically, yeah, we have a sensor, uh, but we have to control. We have to control by using a remote control. So we have a telepresent where it's like we can communicate online, can communicate, from distance. So as I mentioned before, the objective is we want to uh, communicate doctor with the patient without physical contact. So we already did the test to the one of the clinic and hospital, one of the clinic I think and hospital, if I'm not mistaken. The clinic is I did that. The hospital I'm not involved at that time. Uh, so we have to train the doctor actually. So the doctor will use the remote control. It's like a PlayStation, for example. It's like a PlayStation. So remote will will connect to the computer from the computer. Doctor computer will it will control from the computer. So we'll go directly to the patient one by one. So you can ask the patient without physical contacts. So also the Medibot, they have some of the uh, equipment, other equipment like heartbeat, for example, so they can check the patient heartbeat and so on. And this is the example, the first, what we call the first prototype, the second prototype, and then the last prototype. So we have also some kits, but one of the disadvantages that the patient itself must use for example, the heartbeat itself. They have to check by itself. So those are disadvantages. So we ask the company, we ask the investor to coming in. So the investor, when the company comes, they think about the profit. I mean, when it comes, so we can do something else beside from the Mediboard. I mean, for medical purpose, we can do something else. I mean, for the general purpose. So yeah, we're gonna have a meeting I think next week with the company. They are willing to listen. They are willing to discuss and maybe willing to invest because they want to transfer or they want to change this Medibot into general purpose robot rather than just focus on the medical application or for the specific just for general purpose. Yeah. So we will see next week or next 2 weeks what we can go for what we can go from this. Yeah. So this one of the uh, yeah what Medibot can do. So it's like a very simple one. I just can walk around, go around. Okay. We have a sensor, but we need a control. So if you are the first time to control this one, is actually quite difficult. It's quite difficult. So that's why we need to train. Actually, if we go to the clinic, we have to train the doctor first, all the function, so that they can control the movement of the Medibot and so on. Right.
Sir,
Yeah.
I have a question, sir. Actually, when we go for even for a general checkup, they actually check our heartbeat, BP, and all. When we even go for a general checkup, then
Yeah, exactly.
if we
They
use
just go
this,
for a general checkup. But the disadvantage one, the patient itself must do it by themselves. So the doctor will
yes,
check. Yeah. But this is
so
actually,
this may bring a limitations, no, sir.
yeah, exactly. So that's why the company come in. Why don't we change this one to general purpose, not only focus on the medical? You see, because the company comes, they want to gain a. It's a good project. You say that, but we have to change the purpose. change to the other one.
Sir,
Then,
actually, I think instead of nurse who bring all the tools for the doctor, we can keep watch for the doctor, which will automatically follow. This robot can automatically follow the doctor whenever he needs tools. It can be used in such a way.
yeah, I think it's a good idea. We got it's like the medibot like an assistant, yeah, like an assistant to follow the
Yes,
doctor.
sir.
Oh, exactly. Yeah, yeah, we can do that. Yeah. Also, thank you.
Thank you, sir.
Yeah, all right, it's a good idea. Yeah. All right, anything?
Any questions from the participants, sir? Please, you can ask to the speaker. Any questions from the participant side? Please ask your questions. Otherwise, you can chat in the chat box.
So I'm Christopher.
Yeah.
So I want the speaker to elaborate the design of a Smoky Sam project. He has shown some missile object. So I want to elaborate. So whether he did some aerodynamic study on that. Yeah.
All right, thank you. All right,
Yeah.
this is actually a good question, but quite what we call this a confidential one because this one all the detail already give to the company. Yeah, we have a collaboration with the company and some of the understanding. Yeah, we consider a lot of things, especially the what we call these aerodynamic and so on. Yeah, so that's why we did a lot of simulation as well to consider the trajectory because there's a minimum height that this uh, Spocky Sam or this rocket must achieve. Yeah, for example, 1,000 feet, for example, yeah, I to signal the fighter jet. So we achieved that. We achieved that. Now the current issue is basically to launch the rocket to up until 1,000 feet. It's not a problem. Okay, we did a lot of we did a simulation and we see the trajectory and it's good. It's there, 1,000. But in this project, the hardest part is basically to create a lot of smoke. This rocket is basically a very fast. When we try to, you see, when we try to launch, so it's actually very fast. This one is a slow mo. Yeah, this one is a slow motion. But in the real situation is very fast. So what happened? The effect on the smoke is suddenly is like just gone. So how we can actually signal the fighter jet because the fighter jet is actually depend on the smoke. So the issue is on the smoke. Uh, the idea is yeah, there's a portion of material we try to uh, add on some of the portion is 1, 1, 2, 3, 1, 0.5 or something like that. We did a lot of tests and still we actually is this one is still a running project, so we still not finding the best solution on getting the smoke uh, the best ingredient. Well, I can say the best ingredient for making the smoke appear on the sky to signal the fighter jet. Still, I'm not saying that we done, but we still finding the best ingredient. We try to use another ingredient we mix up, and somehow sometimes it's explode. Yeah, it's explode. Totally, it's explode. So that's why we create a lot of prototype here. And this is not only prototype actually. This is the end part because the company want to make sure that once it's launched, then it's explode, and they want this rocket explode everything. I mean, not uh, coming back as a solid. So that's why we are using PLA or we are using a polymer PLA, and we actually did some setting on the printing where we setting up inside this hole, a very hollow one. It's very light, so that one is explode, it will just get a small debris. Yeah, so this is one of the criteria from the one of the criteria from the company. Yeah.
Okay. Thank you, sir. Thank you, sir, for your presentation.
Right.
So any questions from the audience? You can ask. Thank you, sir. Thank you for your nice presentation, showing your case studies about this food printing industry, as well as your current projects in your institution, in your university. Thank you, sir. Thank you. Nice day.
All right, thank you so much to all.
Thank you, sir.
So I leave now. Right.
Yeah, you can listen. You can listen. Okay, thanks your cooperation and thanks your support to conducting this smooth this FDP. Okay, today afternoon we are having the demo session on SLS and SLM and polyjet machines. These machines demonstration given by Dr. Sriram Venkateswar, is a professor in Usman University. Okay, we will meet at 2 o'clock sharply. Now I'm concluding this session. I'm giving the feedback form in the chat box. Please fill this feedback form and you can leave from this chart Zoom link. Hello, Sirisha madam.